Hey guys, this is Anne. So in this video, you are going to learn how to turn a base 10 number into a base 2 number. So the question says, represent the decimal integer in binary notation. This right here is the decimal integer, so 19 is in base 10, and we're trying to turn 19 in base 10 to some number in base 2. So what you're going to do is you're going to take 19 and then divide it by 2, and you get 9, remainder 1, because 9 times 2 is 18, and 18 plus 1 is 19. Okay, so circle the remainder, and now you're going to take 9 and divide that by 2, and you get 4, remainder 1, so you circle 1, which is the remainder. 4 times 2 is 8, 8 plus 1 is 9, so that's correct. And then you're going to take 4, divide that by 2, and you get 2, remainder 0, circle the remainder. And then you're going to take 2 divided by 2, which is 1, remainder 0. Okay, circle the remainder. And then you're going to take 1 divided by 2, and you get 0, remainder 1. You stop here because the number before R is 0, so this is done. So the remainder is 1. And you know that 1 divided by 2 is 0, 0 remainder 1, because 0 times 2 is 0. 0 plus 1 is 1. So now what you're going to do is from top to bottom, right to left, you're going to write the remainders. So 1, 1, 0, 0, 1. This right here is your answer. So 19 in base 10 is equal to 10011 in base 2. Let's look at another example. So now they're saying represent the decimal integer in binary notation, 55. So you take 55 divided by 2, you get 27, remainder 1, because 27 times 2 is 54. 54 plus 1 is 55. Now you take 27 divided by 2, and you get 13, remainder 1. I know this is true because 13 times 2 is 26. 26 plus 1 is 27. And then you take 13 divided by 2, and you get 6, remainder 1. I know this is true because 6 times 2 is 12. 12 plus 1 is 13. And then you take 6 divided by 2, and you get 3, remainder 0. I know this is true because 3 times 2 is 6. 6 plus 0 is 6. And then you take 3, divide that by 2, you get 1, remainder 1. 1 times 2 is 2. 2 plus 1 is 3. So that's correct. And then you take 1, divide that by 2, and you get 0, remainder 1. Okay, if the number before the R is 0, you're done. You stop there. And you circle all the remainders. And from top to bottom, right to left, you write 1, 1, 1, 0, 1, 1, remainder 2. This right here is the binary notation of the decimal integer 55. Okay, let's do one last question. Represent the decimal integer in binary notation, 458. So we know that 458 divided by 2 is equal to 229, remainder 0. You can put these in your calculator to verify that. And then you take 229 divided by 2, which equals 114, remainder 1. I know this because 114 times 2 is 228. 228 plus 1 is 229. And then you take 114, divide that by 2, and you get 57, remainder 0, because 57 times 2 is 114. And then you take 57, divide that by 2, you get 28, remainder 1. 28 times 2 is 56. 56 plus 1 is 57. So that's true. And then you take 28 divided by 2, and you get 14, remainder 0. 14 times 2 is 28, because well, 28 divided by 2 is 14, remainder 0 because 14 times 2 is 28 plus 0, which equals 28. And then 14 divided by 2 is equal to 7, remainder 0. There's no remainder because 7 times 2 plus 0 is equal to 14. And then you take 7, divide that by 2, you get 3, remainder 1. I know this because 3 times 2 is 6, 6 plus 1 is 7. And then you take 3 divided by 2, and you get 1, remainder 1. I know this because 1 times 2 is 2, 2 plus 1 is 3, so that's correct. And then you take 1, and you divide that by 2, and you get 0, remainder 1. And you stop here because the number before the R is 0, so that's done. Check. This is a check. And then you circle all the remainders. From top to bottom, right to left, I get 0, 1, 0, 1, 0, 0, 1, 1, 1. Subscript 2 to indicate that's base 2. And voila! 458 in base 10 is equal to 111001010 in base 2.